In this lesson, we are writing systems of equations from context. So when you're given a word problem and you have to solve a system of equations from that word problem, there are two steps that are very important into setting up your problem. Step 1 is to define the variables x and y. Step 2 is to use the given information to write two equations with x and y. Here we have a word problem, some context, and we want to start just by defining the variables. A paper company needs to ship paper to a large printing business. The paper will be shipped in small boxes and large boxes. Each small box of paper weighs 25 pounds, and each large box of paper weighs 70 pounds. A total of 21 boxes of paper were shipped, weighing 1,110 pounds altogether. Write a system of equations that could be used to determine the number of small boxes shipped and the number of large boxes shipped. Define the variables that you use to write the system. In this example, we are just going to define the variables. The variables are what we need to determine. Okay, so when we answer the question, what do we need to determine, those are our variables x and y. So here are some things that we know. Each small box weighs 25 pounds. Each large box weighs 70 pounds. We know that a total of 21 boxes were shipped. And we know that the total weight of those boxes altogether was 1,110 pounds. So our system of equations is going to help us determine what we need to know. So we're trying to determine the number of small boxes and the number of large boxes that were shipped. So that's what we need to know. That's what we need to determine. So that's going to represent x and y. Now, I'm going to suggest that you always use x and y as your variables because you can always type those into Desmos if you need to graph anything. So x is going to be the number of small boxes, and y is going to be the number of large boxes. For this example, we're going to stop there, and we're going to do another example and find the variables, and then we'll get into some practice of actually writing these equations. Okay, defining the variables here, example 2. Hudson is blocking off several rooms in a hotel for guests coming to his wedding. The hotel can reserve small rooms that can hold 3 people and large rooms that can hold 6 people. Hudson booked a total of 19 rooms, which can accommodate 87 guests altogether. Write a system of equations that could be used to determine the number of small rooms reserved and the number of large rooms reserved. Define the variables that you use to write the system. So again, what we know is that small rooms can hold 3 people, large rooms that hold 6 people. There are a total of 19 rooms. There are a total of 87 guests. What we need to determine is how many large rooms and how many small rooms. So we need to determine x and y. So we're going to be looking for, in this problem, determining the number of small rooms and the number of large rooms. So that's going to be our x and our y. So again, x is going to be the number of small rooms, and y is going to be the number of large rooms. All right, let's do one more, just finding the variables. Okay, so again, let's find what we already know. So we already know Alexa went to the grocery store and purchased cans of soup and frozen dinners. Each can of soup has 350 milligrams of sodium, and each frozen dinner has 650 milligrams of sodium. So we know that a can of soup has 350 milligrams and a frozen dinner has 650 milligrams of sodium. Alexa purchased twice as many frozen dinners as cans of soup. And they all collectively, so all together, they contain 6,600 milligrams of sodium. Write a system of equations that can be used to determine the number of cans of soup purchased and the number of frozen dinners purchased. So we need to determine the number of cans of soup and the number of frozen dinners. So that's going to be our variables, X and Y. So X is going to be the number of cans of soup, Y is going to be the number of frozen dinners. So I'm again going to use X and Y as the variables. So that will be the number of cans of soup, and Y will be the number of frozen dinners. Now we're going to do some examples where we actually find the variables, but then use the variables to write two equations. Okay, Riley and Jace work at a dry cleaner's ironing shirts. Riley can iron 25 shirts per hour, and Jace can iron 30 shirts per hour. Riley worked 3 more hours than Jace, and they ironed 460 shirts between them. Write a system of equations that could be used to determine the number of hours Riley worked, so that's one thing we need to determine, and the number of hours Jace worked. So that's our defining the variables part. So X and Y are the two things we need to determine. So X, so the number of hours that Riley worked, and Y is going to be the number of hours Jace worked. Okay, now we need to write our system of equations. Okay, so going back to what we know. The things that we know are that Riley can iron 25 shirts per hour. And Jace can iron 30 shirts per hour. We know that Riley worked 3 more hours than Jace. And they ironed 460 shirts between them. So thinking about Riley ironing 25 shirts times however many hours he works, which is X. Plus, we know that Jace can iron 30 shirts per hour, so that's 30 shirts times the number of hours that Jace worked, and that number of shirts is a total of 460. Then we have a second equation that can come from this sentence. Riley worked 3 more hours than Jace. So Riley's number of hours, X, was equal to 3 hours more than Jace. So Jace's hours plus 3. So those are our two equations. We don't need to solve these, but if we were to solve them, we would simply plug them into Desmos and we would see where those lines cross. Let's do another example. Okay, Brianna went to a bakery and bought 2 cookies and 3 brownies, costing a total of $9.50. Nevaeh went into the same bakery and bought 10 cookies and 6 brownies for a total of $20.50. Write a system of equations that could be used to determine the price of each cookie and the price of each brownie. So that's what we need to determine. So we're determining, or we need to find with these two equations, X and Y. X would represent the price of each cookie, and y would represent the price of each brownie. All right, now we need to see what do we already know so that we can write our equations. Okay, we know that she bought 2 cookies and 3 brownies, which cost $9.50. So that right there is enough for us to write an equation. 2 cookies plus 3 brownies is a total of or equals $9.50. So 2 times however much a cookie costs plus 3 times however much a brownie costs was a total of $9.50. Then we know that Nevaeh went in and she bought 10 cookies and 6 brownies, which cost $20.50. So 10 cookies plus 6 brownies is a total of $20.50. So 10 cookies times however much a cookie costs plus 6 times the cost of a brownie equals $20.50. So those are our 2 equations. Okay. A law firm is going to designate associates and partners to a big new case. The daily rate charged to the client for each associate is $800, and the daily rate for each partner is $1,300. The law firm assigned 3 more partners than associates to the case and was able to charge the client $12,300 per day for these lawyer services. Write a system of equations that could be used to determine the number of associates assigned to the case and the number of partners assigned to the case. So we need to define those variables because that's what we need to determine. So X is going to be the number of associates and Y is going to be the number of partners. Now let's see what we know so that we can start writing our 2 equations. Okay, we know that the daily rate charged to the client for each associate is $800 and the daily rate for each partner is $1,300. So that's enough for 1 equation, almost. We know that it costs $800 per associate, X, plus it costs $1,300 per partner, Y, and that's a total of how much, which we already saw that they were able to charge the client $12,300 per day. So that's a total of $12,300. Okay, then we see the law firm assigned 3 more partners than associates. So the number of partners, Y, is 3 more than the number of associates. So the number of associates, X, plus 3. So those are our 2 equations for this problem. Okay, Sadie runs a farm stand that sells bananas and grapes. Yesterday, Sadie sold 13 pounds of bananas and 15 pounds of grapes for a total revenue of $55.50. Today, she sold 46 pounds of bananas and 16 pounds of grapes for a total revenue of $131.50. Write a system of equations that can be used to determine the price of each pound of bananas and the price of each pound of grapes. So we need to determine those 2 things using our variables. So we need to determine X and Y, where X represents the price of each pound of bananas and Y represents the price of 1 pound or each pound of grapes. Okay, now let's see what we know. Okay, we know that Sadie sold 13 pounds of bananas and 15 pounds of grapes for $55.50. So that's 1 equation. So 13 pounds of bananas times however much a pound of bananas costs, plus 15 times however much a pound of grapes costs, equals a total amount of $55 $2.50. Okay, next, we see that today she sold 46 pounds of bananas and 16 pounds of grapes for $131.50. So 46 times the cost of 1 pound of bananas plus 16 times the cost for each pound of grapes was a total of $131.50. Leah and Christopher work at a dry cleaner's ironing shirts. Leah can iron 25 shirts per hour, and Christopher can iron 15 shirts per hour. Leah and Christopher worked a combined 13 hours and ironed 265 shirts. Write a system of equations that can be used to determine the number of hours that Leah worked and the number of hours that Christopher worked. So those are the two things that we need to define, and we need to determine as X and Y. So X will represent the number of hours Leah worked, and Y will represent the number of hours Christopher worked. Okay, let's see what we know so that we can set up two equations. We know Leah can iron 25 shirts per hour, Christopher can iron 15 shirts per hour, and how many total shirts could they iron together was 265 shirts. So that's one equation. So 25 shirts times the number of hours that Leah worked plus 15 shirts times the number of hours that Christopher worked equals a total of 265 shirts. Then we have a second equation that can come from this simple little sentence that says Leah and Christopher worked a combined 13 hours. So that alone is a really simple equation that just tells us their number of hours, when you add them together, was 13. So Leah's hours plus Christopher's hours was a total of 13.